A stored procedure is a named collection of procedural and SQL statements. Just like database triggers, stored procedures are stored in the database. One of the major advantages of stored procedures is that they can be used to encapsulate and represent business transactions. For example, you can create a stored procedure to represent a product sale, a credit update, or the addition of a new customer. By doing that, you can encapsulate SQL statements within a single stored procedure and execute them as a single transaction. There are two clear advantages to the use of stored procedures. First, stored procedures substantially reduce network traffic and increase performance. Because the procedure is stored at the server, there is no transmission of individual SQL statements over the network. The use of stored procedures improves system performance because all transactions are executed locally on the RDBMS, so each SQL statement does not have to travel over the network. Second, stored procedures help reduce code duplication by means of code isolation and code sharing, thereby minimizing the chance of errors and the cost of application development and maintenance. The syntax to create a stored procedure in Oracle is as follows. We start with the keyword create or replace procedure, followed by the name of our stored procedure, and then our argument, which specifies the parameters that are passed to the stored procedure. Take note that a stored procedure could have 0 or more arguments or parameters. In or out indicates whether the parameter is for input, output, or for both. The data type is one of the procedural SQL data types used in RDBMS. The data types normally match those used in the RDBMS table creation statement. And variables can be declared between the keywords is and begin. You must specify the variable name, its data type, and optionally an initial value. To illustrate stored procedures, assume that we want to create a procedure, let's say PRC underscore prod underscore discount, to assign an additional 5% discount for all products when the quantity on hand is more than or equal to twice the minimum quantity. The figure on the left gives us the creation of our stored procedure. In here, we can see that if our quantity on hand is greater than or equal to twice of the minimum amount, then we're going to update the products table and set the P discount to have an additional 0.05. And to execute the stored procedure, we just type in exec space the name of our stored procedure. And if we're going to compare our select statement from before we run our stored procedures and then afterwards, we're going to see that there are some items wherein the discount has been updated. In here, we have updated the stored procedure we have seen in the previous slide to indicate an input for our discount. We first check if our input discount is less than equal to 0 or greater than equal to 1. If it is, we're going to show an error message that the value must be greater than 0 and less than 1. Else, we will proceed with our update, with our WPI input as our update. And for us to call this new stored procedure, we're going to type exec, the name of our stored procedure, and then if we have an input, as in this case, we're going to put it inside our open and close parentheses. In here, our first input is 1.5, which is less than greater than equal to 1, so we're going to have an error message. Next, if we're going to execute it and put on as 0.05 as our discount, then we will see that our update has finished. And finally, We further illustrate the use of sequences within stored procedures in these two examples. In the stored procedure PRC add, this is a procedure that adds a new invoice. And in the PRC underscore line underscore add, this is a procedure that adds a new product line row for a given invoice. Take note that in the PRC underscore line underscore add, we're going to get the product price from the product table, and we're going to use WLP as our variable name to which we're going to store the P price from our select statement inside. Until now, all of the SQL statements we have used inside the PL SQL block, trigger or stored procedure have returned a single value. If the SQL statement returns more than one value, we will be generating an error. If we want to use a SQL statement that returns more than one value inside our PL SQL code, we need to use a cursor. A cursor is a special construct used in procedural SQL to hold the data rows returned by SQL query. You can think of a cursor as a reserved area of memory in which the output of the query is stored, like an array holding columns and rows. Cursors are held in a reserved memory area in the DBMS server, and not in the client computer. There are two types of cursors, implicit cursor and explicit cursor. An implicit cursor is automatically created in procedural SQL when the SQL statement returns only one value. Up to this point, all of the examples we have had created an implicit cursor. Meanwhile, an explicit cursor is created to hold the output of a SQL statement that may return 2 or more rows, but could return 0 rows or only 1. To create an explicit cursor, we use the following syntax. We use the keyword cursor, and then the name of our cursor, the is keyword, and our select query. Cursor style processing involves retrieving data from the cursor one row at a time. Once you open a cursor, it becomes an active dataset. That dataset contains a current row pointer. Therefore, after opening a cursor, the current row is the first row of the cursor. When you fetch a row from the cursor, the data from the current row in the cursor is copied to the PL SQL variables. After the fetch, the current row pointer moves to the next row in the set and continues until it reaches the end of the cursor. Once we have declared the cursor, we can use specific PL SQL cursor processing commands, in particular open, fetch, and close, anywhere between the begin and end keywords of the PL SQL block. The following table summarizes the main use of each of the commands. For us to know important data such as what number of rows are in the cursor, or when we have reached the end of the cursor dataset, we can use the following cursor attributes to know these values. To illustrate the use of cursors, we use a simple stored procedure example to list the products that have a greater quantity on hand than the average quantity on hand for all products. In lines 2 and 3, we can see that we have used the percentage type data type. As indicated in the table in the previous slide, this data type indicates that the given variable inherits the data type from a previously declared variable or from an attribute of the database table. In this case, we are using the percentage type to indicate that the WP code and WP disk script will have the same data type as the respective columns in the product table. This way, we ensure that the PL SQL variable will have the compatible data type. In line number 5, we declare the prod cursor. In line number 12, we open the prod cursor and populate it. In line number 13, we use a loop statement to loop through the data in the cursor, fetching one row at a time. Line 14 use the fetch command to retrieve a row from the cursor and place it in the respective PL/SQL variable. Line 15 uses the exit command to evaluate when there are no more rows in the cursor, using the percentage not found cursor attribute, and to exit the loop. Line number 19 uses the percentage row count cursor attribute to obtain the total number of rows processed. And in line number 21, we close the prod cursor. If we try to execute the PRC cursor example, as we can see in here, we are fetching 3 WP codes with their respective descriptions. And as we can see in here, we have processed a total of 3 products.